Welcome to This Explainer. Okay, today we are going to completely transform the way you tackle everyday chores and deep cleans alike. Literally, this is going to save you hours of hard scrubbing. You know that feeling when you're just totally exhausted after fighting a stained bathroom floor? Well, you might actually be fighting a losing battle against basic chemistry.
So let me ask you, are you endlessly relying on elbow grease, just scrubbing until your arms ache? A lot of us kind of assume cleaning just requires maximum physical effort. But what if I told you that by simply using a little chemical matchmaking, you can effortlessly wipe out stubborn dirt and stains? By the end of this explainer today, you're going to know exactly how to let science do the heavy lifting for you.
Section 1, the hidden science of pH. Let's get right into it. All right, let's dive into this invisible battleground. This is the absolute foundation of working smarter, not harder. The pH scale. It runs from 0 to 14, and it's basically a measure of how acidic or alkaline a given chemical is. Right in the dead center, at exactly 7, we have our neutral midpoint, pure water. Anything dipping below that 7 mark becomes acidic. Think of common everyday acids like vinegar, lemon juice, or heavy-duty hydrochloric acid. On the flip side, anything climbing above 7 is alkaline. Stuff like bleach, your standard spray and wipe surface cleaners, and heavy degreasers. Oh, and it's also worth noting that neutral detergents, the ones sitting comfortably between a pH of 5 and 9, are widely used for general, everyday stuff like washing your dishes.
Now here is where it gets crazy. Check out this number, 100,000. The math behind the pH scale is logarithmic. It's not just a simple 1, 2, 3 progression. For every single whole number you move away from 7, the acidity or alkalinity jumps by a massive factor of 10. So a chemical with a pH of 5 is 10 times more acidic than a 6. But a chemical with a pH of 1, that is an astounding 100,000 times more acidic than a pH of 6. This huge jump in chemical power is exactly why choosing the right product is so absolutely crucial. So, before you start any cleaning job, you need to arm yourself with this knowledge. You can almost always find this crucial pH number printed right on the back of the bottle. And hey, if the manufacturer hasn't printed it on the label, it'll definitely be listed on the product safety data sheet online. Always check this number to make sure you're bringing the right tool to the fight. Section 2, the golden rule of cleaning.
Okay, this golden rule is all about how different types of dirt physically react to different chemicals. Here's the secret. Dirt actually has its own pH. To effectively clean it, you have to match opposites. You literally must use an alkaline chemical on an acidic soil and an acidic chemical on an alkaline soil. This dynamic opposition is the magic that breaks the dirt's bond to the surface, meaning you don't have to scrub for hours. Section 3, Mastering Acidic Cleaning Solutions. Let's look at our targets here. A minority of the sticky dirt we deal with is alkaline. Things like calcium deposits, hard water stains, dried urine, brownish limescale on taps and shower heads, and even cement-based residues left over from construction. These alkaline soils usually sit at a highly alkaline pH, somewhere between 11 and 14. So to defeat them, you need the opposite, an acidic detergent with a low pH of between 1 and 4. Now, keep in mind, acidic detergents are generally slower acting than their alkaline counterparts. You often need to give them a longer contact time, around 10 minutes or so, paired with a bit of physical mechanical action to really get the job done. There's a great quote that sums this up. An acidic solution cuts through and liquefies the buildup so it can be washed away. And honestly, this brilliantly illustrates why something like a phosphoric acid-based tile cleaner is just so incredibly effective on bathroom grout. The acidic solution chemically attacks those rigid mineral structures, quite literally cutting through and melting the buildup so you can just effortlessly rinse it down the drain. But you absolutely must handle this power carefully. Never spray acids. You should always use a mop, a sponge, or a squeeze bottle to apply an acidic solution. If you put acid in a spray bottle and aerosolize it, those highly corrosive microscopic droplets can easily land in your eyes, severely damage your respiratory system if you breathe them in, or drift over and completely ruin delicate nearby surfaces. Just don't do it. And speaking of damage, highly acidic and highly alkaline detergents both carry a massive risk of permanently ruining delicate surfaces. Always throw on your safety mask, gloves, and eye protection, and keep strong acids far away from natural stones like granites, limestone, sandstone, and marble, soft metals like copper, aluminum, bronze, and brass, and even delicate textile fibers like wool. The acid will aggressively and permanently etch and damage these materials. No going back from that. Section 4, Tackling Organic Oily Grime.
Now, if the mess you're dealing with isn't in a washroom or a wet area, we switch completely over to the other side of the pH scale to alkaline chemicals. Welcome to the modern world, where the vast majority of wet, sticky dirt you actually encounter is oily, acidic dirt. This grime usually has a low pH of between 1 and 4. We're talking greasy, oily soils in commercial kitchens, lunchrooms, classrooms, or heavy-duty environments like factories, warehouses, and parking garages. Because this oily grime is highly acidic, alkaline chemicals, which sit up at a pH between 11 and 14, are the fastest, most effective choice for tearing right through it. Now, you should really scale the strength of your alkaline cleaner to the severity of the mess. It'll save you a ton of unnecessary effort. If you're just doing a simple daily kitchen mopping, a mild alkaline detergent with a pH of 8 to 9 is going to work wonders. But if you're tackling a brutal once-a-year deep clean of a neglected, greasy floor, you'll need to step up to a heavy-duty tile cleaner with a pH of 11 or even higher. It's all about matching the tool's intensity to the job.
Section 5. Protecting your delicate surfaces. Before you run off to test these chemical matches in your own home or workspace, we need to establish 3 non-negotiable rules of engagement to protect your property and make sure your hard work doesn't backfire. Step 1. Follow the label's recommended dilution ratios closely. Adding more chemical to your mop bucket absolutely does not equal a better clean. Step 2. Never leave strong chemicals on a surface for too long, and definitely don't let them dry out before rinsing, because that causes stubborn stains. And step 3. Always check the specific cleaning guides from your flooring manufacturer and pre-test your solution on a small, hidden area first, just to be totally safe.
I really want to emphasize that first step about dilution because it's super counterintuitive. If you ignore the ratios and just glug extra chemicals into the bucket, you'll leave a thick and visible layer of sticky chemical residue on your floors. This residue acts literally like a magnet, actively attracting and trapping more dirt, which means your floors get dirtier much faster, totally defeating the entire purpose of your hard work. And that brings us to the end of our explainer. So I want to leave you with this final thought. What pH levels are currently hiding in your cleaning cabinet? I challenge you to go check the labels under your sink right now. Look at the numbers, look at the stains you've been fighting, and rethink your entire approach. Isn't it time to ditch the elbow grease and start cleaning smarter, not harder, with the incredible science of pH?